First off, everybody, thanks for doing this. Thank you for doing lightshowpi. That is going to make the software side of things a lot easier for me this year as I do my Christmas lights. This is not my first year to run Christmas lights off of a Raspberry Pi for me, but it is my first year to use lightshowpi to do it. Here is my hardware setup 1.0 that I did a previous year. See, there's the Raspberry Pi over to the left side. The relays are there in the middle, and I've got 6 channels. It's controlling 6 electrical outlets over there on the right. This is my 2.0 setup. So I've learned from my mistakes the first time. I've thought things over a little bit more, learned from my experiences, and this is what I came up with, and this is what I wanted to share and see if you might want to borrow something here to improve your own setup. Now, everything is bolted down. You see the Raspberry Pi is bolted down, the breadboard's bolted down, the terminal blocks, of course, they're bolted down, and the electrical cords are, I can pull on this all day and it's not going to pull on the crimp connections or on the screw terminals. There's nothing that's going to happen there. I put a clamp right here. Actually, this is a door hinge, but I'm using it as a clamp in this application. Now, I thought through the floor plan of this whole thing also as well. One critical thing I wanted to share with you right away is this is my 3-volt DC voltage domain. All my hot signals are here, 120 AC, and my negative hot, or ground is all here. I wanted to minimize the crosstalk between the domains because if you start shorting wires across the domains, bad things can happen. If you accidentally short 2 120 AC signals here, it's not that big a deal. You might turn on some lights that were not supposed to be turned on, but that's it. If you short 3-volt signals, not that big a deal. But if you short 120 AC with 3 volts, you can fry something. So I designed this so that the 3s stay here, the 120s stay here, and negative 120 stays here. Now, if we zoom in to the 3-volt domain. So I've got a Raspberry Pi, and I'm using the ribbon cable to connect. I'm using one of those Raspberry Pi breadboard connectors to run the wiring to my relay circuitry. Now for my DC, for my 5-volt and ground, I'm using secure wires right here. Those are pretty hard to pull out. But for my control circuitry, I'm using jumper cables. So those can come out accidentally a lot more easily, but I'm switching them. I'm changing them all the time as I play around with my lights, see what works and what doesn't. And incidentally, you can see the relays are working right now. I am running the hardware.py in flash mode, so that works. Now, likewise, I'm frequently debugging the electrical sockets all the time. Sometimes I want to bypass the relay for debug purposes, and I just want to connect directly to hot just to see if it's, if the lights are working at all. So I have these quick connects. So I will screw in the wires to the screw-in terminal blocks, but I leave the stripped wires bare and I connect these quick connects here. These are spring-loaded. So you see, here's a wire in the spring load. I can just simply press on here and boom. And you see there's a stripped wire. And I can simply rewire everything really quick between the channels really quickly that way. It's the same reason that I do the jumper wire down here on the breadboard. It's so I can just debug and play with things much more speedily. If I had to screw in the wires every time into the terminal blocks, things move much more slowly. And eventually you can just get tired of it and your end result is not as good. Now you see I've got 2 8-channel solid-state relays, SSRs, and I have 2 additional SSRs right here. These are heavier duty. So one of the drawbacks of an SSR is one channel can only carry about 3 amps of current. So there's not a whole lot of lighting, even if you do LED. Well, with LED you actually can do quite a bit of LED, but not everything you run for Christmas lights are LEDs. I have some inflatables, I have laser lights. I want to control those with the Raspberry Pi as well, because I want to run a cron tab that basically turns on at 5 p.m. at night and turns off at 5 a.m. in the morning automatically. So there's my timer, the web interface, use your cell phone to turn on, off your show, all that. So I want that with the Raspberry Pi, even if I don't necessarily want to do the dancing sequence with my lights. So you can see here I've got a power strip, and maybe I have one of these extension cords that has multiple outlets to plug into, and those plug into these, and those feed into these SSRs, which are in turn controlled by the Raspberry Pi. So these outlets are, or these relays, the SSRs, they are 25 amps. They're rated 25 amps and not just 3 amps. So they can run some heavier duty stuff. So I can have one control signal from the Raspberry Pi basically run this entire power strip. And also, I just want to show you here, I've got two 120 AC wires running into this. So I've got 120 AC running into this 12-channel terminal block, and a second electrical outlet running into this second 12-channel terminal block. And the reason for that is if I want to run a lot of amps, I don't want to trip my circuit breaker. So I can connect these into two separate electrical outlets, running off of two different circuit breakers, and not overload the current on any one load. So yeah, these guys can run up to 3 amps a piece. These can run 25 amps a piece. And so I can run quite a bit of stuff all off the Raspberry Pi. And like I said, just simply run a cron tab, just turn on and off everything at night, or turn on everything at night and turn off everything in the morning without you even thinking about it. Simple as that. I think I mentioned, this is clamped down pretty good. These electrical wires are not, I'm not pulling on any crimp connections, I'm not pulling on the screws or anything. There's no stress in the wires. And I also have a connector right here to keep the wires from getting stray. Another thing I didn't know, when I did my 1.0 setup, I wasn't aware of these guys. So these are terminal blocks, but these are terminal stripes. And what these do is they short all 12 channels together. And these come in like 4-channel, 8-channel, 12-channel varieties. And you don't have to do a whole bunch of elaborate wiring. This guy will just simply short all 12 together, and automatically, you're hot automatically just by feeding this one wire into the terminal block. And then I have this terminal stripe right here that automatically makes all 12 of these hot, which means that I can feed these channels into the relays. That makes things a lot better. Now, I think that's just about it. If you have any questions, feel free to post it online. But yeah, I just wanted to share with you my hardware setup to inspire you and give you some better ideas. And anyway, I really like these quick connects. They really help you switch back and forth and debug things really quickly. All right, well, happy holidays, Merry Christmas, and hope this all helps for you. Bye.